in that case, your number of reaction will change. For example, now at this part, at this joint, again you will be having some forces which you have to determine. If it is a hinge, if it is a pin joint or hinge joint, then there will be two unknown at each joint. Okay? If it is a hinge or pin joint, then there will be how many unknowns? Two. So this joint seems like a pin. So there are how many unknowns at this joint? Two for each. So what about the degree of indeterminacy of this being? How many are? For example, 2 for pin joint, 2 for this pin joint, and 3. How many total are? 10. And how many number of parts? 3. So how much is degree of indeterminacy? 1. Okay? But in this case, it is not a roller, it is a collar support. So for a collar support, there are fixed collar support, there are 2 unknowns. There should be. And for pin collar, there is only 1. See here, this is a fixed collar. Can you see? This support. So it has 2. Like this. This support is a collar. Fixed collar means 2 reaction, and pin collar only 1. So in your book, in that problem, you have this support here. So yes, it is not a roller. So please correct in your book, okay? Do you understand? I give you 2 minutes to discuss with each other. You have 2 minutes to talk.
يساوي صفر. الان عدد الار عدد الار عدد الان عدد 10 أسرع واحد determinacy مدري وش 1 يساوي
هذا نمبر 1.
Please don't start talking about your personal issues. Just keep your discussion only to the lecture. Okay, let's move next. So now, if you see this example, it's pretty simple. It's a pin joint. It's a pin joint, and how many parts?
2. So 3.
How much is R now?
3, 1, 7, 8.
It is hinge.
Yeah,
So
3, 7.
2, 3.
2, 3.
2 to 3. How much?
7.
And how much is 3n?
We have 2 members and 1 teacher. Is the joint
7 is more than 6.
considered or not?
3n equals 6. If it is equal to 0, it is determinate.
Yes.
How much is R?
7.
7.
So how come 7?
It's not hinge.
2 for the hinge, 2 for the
The fixed 3 reaction.
Hinge and fixed roller.
It is a pin or hinge, so 2.
2.
Yeah. 2,
3.
7.
7.
And minus 6. 3 into 2. 2 parts. Is equal to 0? No, it is
1.
So how much is the degree of indeterminacy? 1. So one reaction is extra, and you need one more equation. Is it stable?
No. Yes.
How you can say that? I think it's stable.
Yes.
Let's
Okay, let's talk about this. B.
Two.
Statically determinate or not?
Three.
Nine.
How many are?
Nine.
1, 2, 3.
Nine. Nine reactions. And
Three how many parts?
Three members.
3 members.
Okay.
Two, three.
What about C?
Two, three.
How many parts?
Two.
One.
How much is N?
1, 2.
Three.
Three.
Two.
Three.
Three and
Three. N is 2.
2. It's 1 member.
This whole is one part, like a T. This whole is one part. Okay, how much is R? Silent please.
Two fixed and two hinges.
Silent please. Please silent. You can ask from me. I am like, yes. How much is R for C?
Two fixed and two hinges. So 3, 2, 10.
2 fixed, 6, and 4, 10. Yes.
10.
So it is statically indeterminate. What about D? How many parts for D?
1, 2, 3, 4. 4.
Two, three.
This is not the part I explained you before. It is a part of support. This is a collar support. But here you can see a pin, so there is only one reaction. If it is not a pin, there are two reactions. Here you can see a pin, so there is only one reaction. It is a pin collar, and before it was fixed collar.
Yeah. So one.
So 1, 2, 2 and 2, 4, 6 and 3, 9. So R is 9. And how many parts? 1, 2 and 3. Determinate, statically determinate. Oh my God. Now let's talk about the concrete frame. Okay. Now this concrete frame is not that simple. So what is the way we pass one section through the frame? Okay. What is this support? Support here. It's a roller. Okay. Yes. And what is this support?
Hinge.
So 3. And then 3 more from each member. Now these two reactions, they are equal but in opposite directions.
Yes.
Okay, I tell you, I give you one example. Let me do here the same example. Your board is in a very poor condition. It really makes me upset because so many dots and so many colors. I raised this issue many times with your college administration, but
It's not suitable for this college. This board. I need like 3 times.
I'll take it. You will take it? Now, you know Mr. Umair, he is now responsible for all these things. Not only for the civil department, but also for the whole college. Yeah, so he's the right person, and luckily he's sitting here with us. So he will raise this issue with the vice dean or maybe the dean that we have this problem. Anyhow, let's come back. But as a person, I raised this issue many times on my personal grounds. So what is the best way? It's the best way from every close, for example, this is one closed part, this is one closed part, we will pass one section from here. Okay? If you want to make this frame more complex, like this, okay, make it. Here you want fix. So, you can again pass one section here. So now there are 2 sections. And from every section, this point, you will be having 3 reactions. And these 3 reactions are equal but in opposite direction for these two members. And here. So mean 3, 3, 3. How many?
9.
3, 3 and 3.
18.
This is how you can calculate the reaction. And what about the number of parts? 3.
1. It's 1.
There are
2, 3,
think. There are 2 closed loops and there are 2 members through which your section is passing. Can you see?
3, what? For the graph, what?
For example, here n is equal to 2. Let me tell you. Your n is equal to, there are 2 closed parts and the section is passing through the 2 members. Okay? In other words, just keep this thing in your mind. There are 1, 2 and 3 members through which your section is passing. Okay?
Okay.
1, 2 and 3. So 3 into 3, 9. The equation is same. R minus
3.
3.
but n is the number of parts through which your section is passing, or you can call the closed loops 1, 2 and 3. One and the same thing. So 3 into 3,
18. Will be 9.
9. Its degree of indeterminacy is 9. Okay, this is this problem. Let's come back. Let's come back to. I quickly jumped. Here, we were here. Now please see here. For example, for this structure, oh, it is the same. It is the same. So the degree of indeterminacy is 9. And what about this? R is how much? 3, 3 and 3. 9. And how many parts? 1 and 2.
Yeah. Good section.
So degree of indeterminacy is 3. Yes. Okay. So what about this case?
We have 2 sections.
So we have how much is for part B? For part this is B part, I think, or C. For part C, how much is R? First calculate R.
1, 4, 7, and 2, 9. 9. R reactions. Oh, without the sections.
16.
18.
Pass the section. Okay, I do this.
Has no closed loop.
Yes, it has no closed loop, but there will be number of parts in it. What was the shape? This, and then this,
Yeah, with X.
and then here is a roller,
Yeah.
or
All
change, and then fix.
Fix, roller. The
Yeah.
final one is fix, roller.
Okay, I cut it from here. To
So teacher, any possibility of shear failure, we will take the sections.
we will take the vertical section through each, part, like this. Now if you see, so there are how many parts? One is this part, another is this P part, this, and then you have this part, and the final one is,
Yes.
so your n is how much? 4.
Eight.
N is number of parts. You can say
Three sections.
3 sections. But in this case, because of this, but what should I say? The irregular type of structure, there is one more part here. Okay? This idea is equally applicable for the previous case. For example, if you have this structure, you break it from here. Now your whole structure is basically 2 parts. Like this is the one part, and this is the other part. But in that case, luckily we have two members, and your section is passing through all these 2 members. So we have these 2 things equal. Number of parts is equal to number of sections. But in this case, there is no closed loop. So you have to see, just pass a section through each vertical member, the horizontal member, and now you can see how many number of parts. 1, 2, 3, 4. 4 parts. 1, 2, 3, 4. Okay. So how much is R? 3, 3, 3, 9. 3.
No, 4 here. 1 on left and 3 on right.
For each section, we take 3 reactions.
I'm calculating R, number of reactions.
Okay.
18.
3, 3, 3.
18.
3, 3, and 1 and 2.
18.
18.
18, yeah.
4 parts. 1, 2, 3, 4.
18 more than 12.
12. Minus 12, yeah. Would be 6.
6. The degree of indeterminacy is 6. What about this structure? This is the same or something different?
Yeah, the same. Just everybody like
Doctor, I have a question.
Yes.
Why we didn't do the section for the other drawing? Before this one.
This?
No. Yeah. For example, 2.5. Yeah, for this.
For this, it is a pin connected structure. This is steel. I told like concrete. It is steel. I give you some time to discuss. Okay? Is it? Yeah. You can close it.